Hi students, today I will be teaching you the refraction of light, that is the continuation of the refraction of light which I have taught you in the last class, and today in this class I will be teaching you the topics, that is number 1 the cause of refraction, number 2 the effect on speed, wavelength and frequency due to refraction, number 3 the conditions for a ray of light to pass undeviated on refraction. So let's start the first topic of our chapter. The name of the chapter is refraction of light, which is very important for the students of class 10 for the ICSE purpose. So in the first topic, I will be teaching you the cause of refraction. Students, what is the cause of refraction? Why the refraction occurs? What is the reason? Are you thinking something? Yes, when you know that when a ray of light moves from one medium to another medium, what happens to the speed of light? The speed of light in the second medium changes. Why? Because in the previous classes I have told you the speed of light in different media is different. Say the speed of light in air or vacuum is 3 into 10 to the power 8 meter per second, whereas the speed of light in glass is 2 into 10 to the power 8 meter per second. So when the ray of light comes from air to glass, while it was coming in the medium air, the speed was 3 into 10 to the power 8 meter per second. As soon as the ray reaches in the medium glass, suddenly the speed of the light changes and it becomes 2 into 10 to the power 8 meter per second. Due to this change of the speed of light, what happens? The direction of its path changes, and this is called refraction. So you can see one diagram I have given over there. See in this diagram what happened? A ray of light is coming from rarer to the denser medium. Here one rarer medium, this is one rarer medium, and this is the denser medium. This ray of light is coming say from air to glass. So when it was traveling in the medium air, the speed of light was, here it is shown 1c. Now when it is coming in the glass medium, the speed is decreased, and due to that reason what happened to the speed, to the direction of its path? It changes, it is bending towards the normal, and this is what we call the refraction. So therefore, what should be your answer for this question? This is a very important question which comes in the ICC examination. Your answer should be the speed of light in different transparent medium is different. So when a ray of light moves from one transparent medium to another, changes its speed, hence changes the direction of its path. So due to that reason, the refraction occurs. Next topic, effect on speed, wavelength and frequency due to refraction. Now due to refraction, is there any change of the speed? Is there any change of the wavelength? Is there any change of the frequency of the light ray which is used? Let's discuss. At first I'll discuss about speed. You know, when the ray of light moves from one medium to another medium, the speed changes, because while the ray was moving say in the medium air, the speed of light in the medium air was almost 3 into 10 to the power 8 meter per second, and when it reaches in the water medium, then the speed of light changing over there. So when a ray of light moves from one medium to another, its speed changes whenever it is moving from rarer to the denser medium. See in the first diagram, in this diagram I have shown there, a ray of light is moving from rarer to the denser medium. When a ray is moving from rarer to denser medium, what happened? The speed of light, the speed of the refracted light, the speed of light means the speed of the refracted light is decreased. Now see the second diagram. When the ray of light is coming from glass to air medium, here the speed is mentioned, you can see here, and in the air medium the speed is also mentioned. So what happened? The speed of light in the second medium, that is the refracted light, the speed is increasing. So when a ray of light moves from denser to the rarer medium, then the speed of light increases. So in this way, the speed of light in the medium changes when the ray of light moves from one medium to another medium. So next we'll see how the wavelength of the light ray changes when it moves from one transparent medium to another. Just see here, when the ray of light moves from one transparent medium to another, like speed, the wavelength also changes. Now, why the wavelength is changing? Since the speed of light is changing while it's moving from one medium to another, therefore, the wavelength of the light ray also changes. So, when the ray of light moves from rarer to the denser medium, what happens to the wavelength? The wavelength of the light decreases. And when the ray of light moves from denser to the rarer medium, what happens to the wavelength? The wavelength of light increases. Now, there is a relationship between the speed, wavelength, and frequency. Now, how the speed, wavelength, and frequency related to each other? See this relation I have given there. V is equal to F into lambda. Here V stands for the speed of the light, F stands for the frequency of the light, and lambda stands for the wavelength of light. This is how the speed, wavelength, and frequency are related to each other. Let's see what happens to the frequency of the light. As you know that the frequency depends on the source which is producing the light. Therefore, when the ray of light moves from one medium to another medium, its frequency does not change. Why? Because the frequency depends on the source of light. From where the light is emitting, it depends on that. If the source is changed, then the frequency will be changed, or else the frequency of the light ray remains the same. The frequency will be not changing when the ray of light moves from one medium to another medium. Now, if you change the source means the source of light. Say initially you are giving from one point source, the light was emitting. Now we are changing the source. So when the source of the light is changes, then the frequency will be changing, or else the frequency will not change. It remains the same. So next slide we'll see the condition for a light ray to pass undeviated on refraction. This is a very important questions for you. What are the conditions for a light ray to pass undeviated on refraction? On refraction, you have known that sometimes the ray of light has to pass undeviated, means there would be no deviation of its direction of the path. So in which condition the ray of light moves undeviated? You know that when the ray of light falls normally onto the surface, at that moment the ray of light pass undeviated. See the diagram over there. Here the ray of light is coming from denser to the rarer medium, and here the ray of light is falling normally onto the surface. Normally means it is perpendicular to the plane of the surface. See, this is the plane of the surface, and this is the incident ray. This angle will become 90 degree. In this angle will be 90 degree. So that is your normal incidence. In this case, the angle of incidence will be 0. It is mentioned over there. You can see angle of refraction will be 0, and angle of reflection is also 0, whereas the angle of deviation is also 0. So when the ray of light falls normally, or when the angle of incidence is 0, at that moment the ray of light passes undeviated. This is condition number 1. Now the condition number 2. when the refractive indices of both the media is same, at that moment also the ray of light moves undeviated. See here this diagram. In this diagram you see this is medium 1, I have used here glass. This is medium 2, I have used here glass. Now when the ray of light is coming here, this is the incident light and this is the refracted light. Is there any bending of the ray of light is there in the second medium? No, there is no bending of the light ray in the second medium. How can you understand that? See, the angle of incidence here is how much? Angle of incidence is 45.1 degree. Here the angle of refraction is 45.1 degree. So there is no deviation of the path of light ray. So as a whole there is no deviation. Why there is no deviation? Because the refractive index of both this medium will be same. It is coming from glass to the another glass and the refractive index of the glass remains same. So in this way, when the refractive indices of two media becomes equal, suppose the ray of light is coming from air to another medium where the refractive index is equal to that of the air, then in that situation what happened? The ray of light will not bend, it passes undeviated. So here I can show you also how this ray of light is coming not bending with the help of experiment. Suppose here the ray of light is coming from this medium, I have taken air, this medium I have taken glass. Now let's see if the ray of light falls over here, what happens? Now a light ray is falling. When the light ray is falling over here, what is happening? It is bending in the second medium. Now why it is bending? Because in the second medium the refractive index is not same as the first medium. Now if suppose I'll change the second medium, in the second medium instead of glass I'll bring it air. See what is happening now? I'll change this one. Now second medium become air. So when the same ray of light was falling, how it is going? It is moving undeviated. There is no deviation of its path. If you find this angle, angle is same. This is 45, this is also 45 degree. So is there any change of the direction of the path of light ray? There is no change of the direction of path of light ray. Why? Because the refractive indices of these two media are the same. If this will be your medium 1 and this is your medium 2, since the refractive indices are same, therefore the ray of light from while it is moving from medium 1 to medium 2, it passes undeviated. So now I'll change this medium. This is your air, this medium is air. Now this medium I'll give some other medium, say I'll give it another medium, a denser medium it is given, some other medium it is given in this. Okay, now see, when the ray of light is coming from air to this medium, what happened here? Let's check, it is bending. So bending means the refraction is taking place because this is the denser medium, this is the rarer medium. Now if suppose the ray of light falls normally in this situation, what happens? Let's see. Just see here, the ray of light is falling normally onto the surface. What happened? In this situation, there is no bending of the ray of light is taking place. So therefore, there is no deviation of the path of light ray. That means here angle of incidence is 0, angle of refraction is 0, and angle of deviation also becomes 0. So there are two conditions for the ray to move undeviated. What are these? Number one, when the angle of incidence becomes 0, or when a ray of light falls normally onto a surface, at that moment there is no deviation or the ray passes undeviated. And number two case, when the refractive indices of both the medium will be same, during that moment the ray of light also passes undeviated. So this is your condition number 2 which I have given you. Understood now? So this all about the topics today. Thank you so much.